All right, so from test 5.4 and 5.5 here, we're going to look at the two word problems here using our right triangle trig, numbers 7 and 8. All right, number 7 said you had a large totem pole in the state of Washington that is 100 feet tall. At a particular time of day, the totem pole cast a 200-foot long shadow. Find the measure of the angle of elevation to the nearest degree. So we're going to find an angle in this problem. Now let's draw a picture of it here. So I'm going to draw totem pole, and we'll draw the ground here. Okay. And so notice I'm not really worried about my measurements. I'm just trying to figure out, how can I get a right triangle? So if I shoot an angle of elevation up to it here, it's going to make a hypotenuse, and we're going to assume that that totem pole is not leaning, and it's going to make a 90-degree angle with the ground. Okay. Now let's fill in what's missing here and what's given. So it says that the totem pole is 100 feet tall. So we put 100 feet on this leg. And the totem pole cast a 200-foot long shadow. So now let's think about this. A shadow, where's a shadow at? Okay, when the sun hits your body, is your shadow in the air or is it on the ground? Well, it's on the ground. Okay, so a lot of people that miss this problem put 200 feet here on the hypotenuse. Okay, so if this is the totem pole, the shadow is going to be on the ground down here. Okay, now let's see what we're trying to find. It says find the measure of the angle of elevation. So the angle of elevation is always at the bottom of formula with the ground. So I'm going to call it theta. Okay, now let's find this angle. So from the two sides that are given here, from my angle, this is the opposite side and the adjacent side. So if I'm dealing with opposite and adjacent, that would be tangent. So the tangent of the angle is equal to opposite over adjacent here would be 100 over 200. So now I'm not going to cross multiply. Since I'm finding an angle here, I'm just going to do the inverse tangent of that ratio right there. So let's see, inverse tangent now of 100 over 200. So let's see, to the nearest degree here, 26.5, so that would round up to 27 degrees. Okay, now number 8 here says that we have a slide. Okay, so it says a slide 5.1 meters long. And that's talking about the slide part of the slide, okay, not the ground distance. Makes an angle of 35 degrees with the ground. It says to the nearest tenth of a meter, how far above the ground is the top of the slide? So let's draw a picture of a slide here. So here we go. We got the ladder going up to it. And then we're going to be sliding down here. Okay. Now, all right, let's fill in our measurements here. So we got the slide is 5.1 meters long. A lot of us here put the 5.1 meters down on the bottom leg. But if we're talking about the slide part of the slide, that's the slanted part. So that's really going to be sort of the hypotenuse here. Now, it says the slide makes a 35-degree angle with the ground. Okay, so here's the ground. Here's the slide part. So there's my angle, 35 degrees. Now, to the nearest tenth of a meter, how far above the ground is the top of the slide? So my height here would form a right angle. And so that leg is going to give me the height. I'm going to call it x there. Okay, now let's see how we can find that height right there, that unknown x. So from 35 degrees here, x is opposite, and the 5.1 is the hypotenuse. So if I'm looking at opposite and hypotenuse, then we use the sine ratio. So the sine of the angle, so sine of 35 degrees equals opposite over hypotenuse, so x over 5.1. Okay, now we're not finding an angle like in the last problem, so we can just put this over 1 and cross multiply. X times 1 is x. And we'll get here 5.1 times the sine of 35 degrees. If you're taking the ACT would probably put this as your correct answer because it doesn't expect you to have a calculator. But we have a calculator, so let's see what that actually is. So 5.1 times the sine of 35 degrees. Okay, so to the nearest tenth here, that's going to be about 2.9 meters.